everyone, Bhavya this side from JNtech Networks. So today we are going to see today is the day one of Python. Okay, this is the first session in Python of Python in English. Okay, so today we are going to discuss the intro part of Python, introduction of Python, like what is Python, who can do the Python course, like types of Python, where we can use Python, the like how to use Python, the softwares that you are going to install with Python. So in this session, we will see the intro part as well as the prerequisites, like who can do Python. Basically, Python is for anyone, like anyone can enroll in this Python. Okay, Python, we have two types of Python. First, we have core and then we have advanced. Okay, in this core, we have the basics part. Okay, we get in the core, we have the basic part the fundamentals of Python, variables, data types, conditionals, control flow, and the if else statements, loops, functions, modules and packages, file operations, as well as classes and objects, like the little part of OOPS concept inside code. So this will cover the basics part. And in the advanced Python, we have the advanced libraries, like we have the networking libraries, we have the GUI libraries like Kinder and Turtle. We have the OOPS concept, which is very important in Python. And then we have the CGI decorators and generators, etc. So in the advanced Python, we will mostly cover the libraries and the frameworks we can use with the Python as well as the projects. Okay, so the Python is divided into two parts, like the core and the advanced. Okay, so we will see the core first and then we will move with the advanced. So what is Python and who can do Python? Basically, Python is for anyone. Anyone can enroll in the Python core. Okay, but for the advanced, you need to have the knowledge about the core Python. Okay, so anyone can do this, and let me tell you, it is not necessary to do like C, C++, any sort of programming before learning Python. You just have you just know the basic knowledge of that system, and that is enough. Okay, like how to operate the system, how to download things, etc. Okay, so anyone can do Python. Okay, so there are no prerequisites, like you just start Python learning. Okay, then. So what is Python basically? Python is a programming language. Okay, so Python is a programming language. That's it. Now let's discuss the features of Python. Basically, we say that Python is an open source. Okay, why Python is open source and what is the means of open source here? See, we have three types of softwares like open source, we have freeware, and then we have paid. Open source means we can use it for free first, and second, we can modify the source code of Python. Okay, like we can contribute to the source code of Python. So that is why Python is an open source, and that is why Python is so flexible. Okay, so Python is an open source programming language. Then Python is easy to use and easy to understand. Now Python is easy because Python is written in high level language. Basically, we have three types of languages like high level, low level, and mid level. High level, low level, mid level, and then low level. High level means which is close to human language. Okay, mid level is not so close to human language or not so close to machine language. And low level is like it is close to machine language. And the machine can only understand binaries. So low level, we have assembly, as a low level programming language. And in the high level, we have Python because Python is like close to human language. Like Python is written in English. When you see the code of Python, we have print. Let's say we have print hello world. Okay, so this is a Python function print. Now print is used to print something. Okay, so a user or a non-technical person can easily understand. Okay, print is a function that is used to print something or to display something. So that is why Python is easy to understand and easy to use because Python is a high-level programming language. So we have one more point. Python is a high-level programming language. Okay, so Python is open source, means we can use it for free as well as we can contribute to the source code of Python. So we have open source, we have freeware, and we have paid. Open source software is like we can use it for free as well as we can contribute. Freeware is like we can only use for free, but we cannot contribute to the source code or we cannot modify the source code of the program. And paid is like paid, you have to pay for the for its services. Okay. Next, Python is a general purpose. Okay, so why Python is a general purpose? Because Python can be used everywhere. Like we can use Python anywhere in every domain, basically. So suppose we have a website. Let me write a domains here. We have web development. We have machine learning. We have data science. We have automation, networking, security, and application development, etc. So Python can be used anywhere. Okay, like Python can be used with web development. Like you can learn the basics of Python and then you can move for Django. Django is a Python framework. Okay, so if you want to do Python with web, like web with Python, then you can go for Django. If you want to learn Python with ML, then you can go for like libraries of ML. Look like TensorFlow, Keras, etc. And for data science, you can go for Pandas, NumPy, Matplotlib, Cbon, etc. For the automation, you can go for Selenium, okay, or PyAuto GUI. And for the networking, you can go for like we have many libraries like request, etc. For the security, like you can use Python for security in like you can create malwares, you can create tools out of it. Okay, so you can use different libraries inside security. In the app development, you can use like multiple libraries, and you can even use for GUI, okay, graphical user interface. Then you can use Inter and Tutor. Okay, so basically Python is a general purpose because Python can be used everywhere, like in every domain, blockchain, okay, and like AI, NL, or like machine, like neural networks, deep learning, etc. So you can use Python everywhere. That is why Python is in trend. So Python is a general purpose. And now the question arises, why Python is a general purpose? Okay, so why Python is a general purpose? And why we can use Python everywhere? Because it is open source. Because it is an open source programming language. Now, what is the open source? Because you can modify or contribute to its source code. So that is why the most developers come and contribute to the Python frameworks and libraries. That is why Python is a general purpose. So we have libraries and frameworks. Okay, like we have many libraries and many frameworks, and Python is an open source. That is why we have many libraries and frameworks. So like most of the developers come and contribute to the source code of Python. That is why it is a general purpose because of its libraries and frameworks. Like Python has vast amount of libraries, frameworks, and modules, etc. Okay, so that is why we can say that because of all these features, we can say that Python, hence Python is a powerful language. Okay, so these are the features of Python. It is a high level. Okay, it is an open source. It is easy to understand and easy to use. And then it is a general purpose and it is powerful language. Now, one point is Python is dynamic in nature. Okay. Now, what is the means of dynamic here? Is suppose if you ever learn that C language, then you can understand this example. Suppose there is a C or C++ code. Okay, you are writing a code in the C or C++ language. Then in the C and C++, you have to code first. You are writing a code, and then okay, and then you compile it, and then you run this. But in Python, there is no compilation process. You code and then you run. Okay, so that is why Python is dynamic in nature. Like first in the C or C++, you have to code it, you have to compile it, and then you have to run it. But in Python, you just code and run it. There's no compilation process. Means first you have to create a .c file, then you have to compile this, and then you have to run .exe file. This is a whole a long process. Okay, but Python is very flexible in nature. Okay, so we can call here Python is flexible in nature, not dynamic. Because in this you can code and then you can run it. Now Python is dynamic in nature. Okay, so why Python is dynamic in nature? Because see, in the C or C++, when you are assigning a variable, suppose A is a variable is equal to 10. Okay, A is a variable and you are assigning 10 value to a variable A. Okay, so in the C++, you have to define that you have to tell a variable that what kind of value you are storing. For example, you have to tell the C or C++ interpreter that I am storing an int value, like integer, it is a number that we will discuss later. So in the C or C++, you have to tell a C or C interpreter that I am storing this type of value, and the value is 10. Okay, so here you have to just define the value you are storing, type of value you are storing. But in the Python, you just define anything. Like you can define anything, like you can define numbers, integers, floats, complex or strings. So here you don't need to define, or you don't need to tell to variable that what kind of value you are storing. Just create a variable is equal sign and then your value. So we are assigning 10 value to A. But in C or C++, this is a whole a long process. First, you have to define it. Suppose this is a float value, then you have to write float here. Okay. So we are just storing the float value. So you have to define, or you have to tell a variable that this type of value I am storing. This is C or C++ code. But in Python, there's no barrier. You can just use the variable, name your variable, and then write whatever you want, or whatever value you want to store. So that is why we say that Python is a dynamic in nature. Okay, so these are the features of Python. Can write here. Okay, so these are the features of Python. Now, Python 2 versus Python 3. Basically, you have heard about Python 2 also. Okay, so now we are running the Python 3.11 version, 3.10 around. But previously we have Python 2. Now Python 2 is not in no more use. So, but what is the difference in Python 2 or Python 3? So they are just a syntax difference. Like suppose in Python 2, you write Python, you write print space hello world. This is the code of Python 2 to write print or to print something. Python 3, you write print hello world. In this, we are using the parenthesis, that is the round brackets here. Okay, so this is a difference. And we have like many differences, many syntax difference. In the Python 2, you use raw input, but in Python 3, you use input. Simple. In the Python 2, you use range, X range. In Python 3, we use range. Simple. Okay, so there's a like some syntax difference as well as some libraries are modified, and maybe some libraries that are not in Python 2 are we are using in Python 3. Or maybe some other libraries which are in the Python 2 we cannot use in Python 3. So this is just a like minor difference. Basically, Python 3 is better than Python 2. Okay. So this is just a minor difference. Like the syntax, we have like many more like differences. Okay. Now let's see the history of Python. Who invented Python? So basically, Python was invented by. Okay, so Python was invented by Gideon and Russell in 1991 at CWI Netherlands. Okay, so Python, the inventor, the developer of Python was Gideon Russell, and he developed in 1991. So, like he just launched Python 2 first, and then the developers all over the world update the Python 2 to Python 3. Okay, so the inventor of like Python is Gideon. No. Why Python is called Python only? Like why Python is called Python, not the other name? Okay, like because like Python names derived from like comedy show that is. Okay, so this was the favorite circus show of the inventor. So he just named, oh Monty, I just forget Monty's Python Flying Circus Show. Okay, so from here we have the name Python. So he just picked the Python from its favorite comedy show. Okay, so we can put it is a comedy show, basically. So that is why we call Python like Python. Okay. Now why we learn Python? Why it is important to learn Python? Like you can do anything. It is not important. But Python is in like a trend. And if you want to start your career in IT, so Python is the right choice. As well as Python can be used everywhere. We have many features. First, it is easy to use and understand. Second, it is an interpreted language where you don't need to compile anything. You just write the code and you just run. Okay. It is an object-oriented programming language. Oops. Then we have the open source. It is open source. Then we have the vast amount of standard libraries and frameworks. Then it is a GUI programming support. You can like create GUI apps or applications or the programs out of the Python with the help of Kinter or Turtle. You can even create animations. Okay. It has a dynamic memory allocation and it is like wide range of libraries. So we have like many reasons to learn Python. Okay. And rest is your choice. No. Where is Python used? As I said, Python can be used everywhere. Like it is used in data science, data mining, desktop applications, console based applications, software development, okay, artificial intelligence, neural networks, deep learning, and machine learning, web applications, enterprise applications, or etc. Like we have like computer visions, blockchain, etc. We can use Python everywhere. That is why Python is in trend and it is very powerful language because it has like many libraries and frameworks. Okay, so let me tell you famous Python popular libraries. Okay, so first we have Django for the web development. If you want to learn the website development with Python, then you can go for Django. Okay, after learning HTML, CSS, JavaScript, Bootstrap, React.js, you can go for Django. Then we have for the ML or for the DS, we have the pandas, we have the NumPy, we have the Matplotlib, we have the Seaborn and ScrapPy, okay, etc. Then for the GUI, we have the printer, and we have the turtle. For the automation, we have Selenium. It is a very powerful language, like very powerful library. Okay, and we have the Pi Auto GUI. It is also too good. Okay, so we have like many libraries. So like there are many like more TensorFlow. We have Keras, we have PyTorch, we have PyGTK, and PyJS, Scikit-learn, etc. So we have many libraries and frameworks of Python. So it's totally depends on your career, like what you will choose with Python. See, if you want to become a web developer, then you can go for Django with Python. If you want to go for ML or DS, you can go for these libraries. If you want to go for GUI with Python, then you can go for these libraries. And if you want to go for automation with Python, then you can go for Selenium or PyAuto GUI. If you want to go for networking, you can like learn socket programming as well as request modules, etc. So it totally depends on your career, what you will choose with Python. Python basically is a programming where you can use it anywhere. Okay, so this will a plus point if you learn programming like Python as a in your career. Okay, so after learning the basics of Python, yeah, the basics, yeah. After learning the basics of Python, you can go for advanced. Okay, in the advanced, we have the libraries and we have the frameworks. So you have to choose which libraries you suit best for your career, for a field. Suppose you want to go for web, then you can go for Django. So basically, after learning the basics of Python, you have to choose which library you have to do with your career, with your field. Because like no one can learn the whole programming, it is not possible or it is of no use. Like your field is, for example, your field is web and you are learning kinder or turtle, so what is the use of it? So choose that wisely, like which libraries you want to do or which you want to not do. Okay, like which you want to left. So it's your choice, and rest it depends on your field. Then we have the installation process of Python. Okay, so how to install Python, and like yeah, pre-request is like anyone can do Python. So installation process for the sessions we will going to use Python as a software as a okay. So we can write so yes. We will use Python 3. Python just 3. Okay, and we will use VS Code as a IDE. Okay. So what is IDE? It is integrated development environment. Means IDE gives you the environment where you can code happily. Yeah, where like you can code easily. So IDE provides like lots of features and functions. So you can apply this with the code that we will see how to use IDE. So we will use Python 3 VS Code. Like we have many IDEs. You have heard of Python. We have VS Code, that is Visual Studio Code. and which is also known as VS Code that we will use. Okay, we have Atom, we have Sublime, Editor, etc. Like we have many IDs, so you can choose like whichever you want to like do. So basically, VS Code is for the beginners. If you are studying the Python now, so you can just start with the VS Code. And if you are a advanced user, then you can go for PyCharm or Atom. Okay, Sublime is like not good. You can go for Jupyter also. This is especially for the for running the pandas libraries like pandas NumPy for the DS or ML. Okay, so we have many IDs, so you can choose whatever you want. Like but VS Code is like very comfortable. The VS Code interface is very easy to understand, and it is for beginners. So you can go for VS Code. That is Visual Studio Code. Now from here, to install Python in VS Code, so open your browser. You can search for Python download. Okay. So go to the python.org, the official website of Python. Let me zoom this. Yeah. Okay, so the official website python.org. Click on this. Okay, click on download. After downloading, you have to install it. So this installation process is also very straightforward. In the installation process, while you are installing the Python, there is an option will pop up will like come that you have to add Python to path. Okay, so you have to tick that option. So note, it is very important. Caution. So you have to tick Python option that is add to path. Okay, it is very important. So don't forget to add your Python to path. Otherwise, it will throw error afterwards. Okay. So after that, the installation process is very straightforward. Now, for the VS Code, you have to go to the website Visual Studio Code. Okay, here you have to search for code.visualstudio.com. Click on this and download for Windows or your Mac or Windows or Linux. Install it. After it is also very straightforward. The installation process is very straightforward. So let me open the VS Code. Acha. Before that, you have to confirm that the Python has been installed in your system or not. So open the CMD, your command line. Okay, here you have to type Python, just Python. Hyphen. So when you see the Python version, so just ensure that the Python has been installed successfully. Okay, so cross this. Now we have to open the VS Code. So this is the interface of the VS Code. It is very easy. Cross this. Now here, click on this extensions. Here you have to search for the extensions. Okay, so here search for run. Okay, so click here, code runner, install this. Okay, and then we have Python. Search for Python. And then click on here, Python Microsoft. Click on here. After that, you have to install it here. Yeah, prettier. Okay, install this. After that, you have to install VS Code icons. Okay. Click on this, install this. So you have to install 4 extensions with VS Code. That is, let me mention this: VS Code, Python, VS Code icons, Run, which is code runner, and last prettier. Okay, this will format your whole code. So these are the extensions that you have to install after installing VS Code. And you can install from here. Okay, so cross this. Now restart your VS Code. So like restart this. Okay, cross this. Now let's make a folder here. Right click, new and folder. Okay, let's put here Python. Simple. Or Python session 1 underscore 1. Open drag and open this with VS Code. Okay, cross this. Now here in the file option, you can do anything like you can add file, you can like create new file, you can create any type of file like any extension file like C file, Java file, JavaScript file, etc. You can open the window. Okay, you can open any file like any pre-existing file, you can open any folder, etc. In the preference option, you have option of color theme. You click on it and choose your color theme, like whatever color you want, you are comfortable with, you can choose it. So I'm comfortable with the dark. So yeah. Okay. Now here, after opening a folder inside VS Code, you have the option of plus. Okay, this is for making file, this is for making folder, this is for refresh. So we have to create a file. So click on here and type here your file name. Let's say file.py. So the extension of Python is .py. That is .py. Like we have many extensions like .txt, .c, .java, .js, etc. So the extension of Python is .py. So you always have to save your file, your Python file with the help of .py. Okay. So this is all about the intro part of Python and the installation process. In this, we have learned like how to like what is Python. Python is a high level programming. Features of Python, open source. It is open source, easy to use and understand. Why it is easy to use? Because it is a high level language. And what is high level? It is written in English. English. Like it is close to human language. It is a general purpose programming language because it is like many libraries and frameworks. It is powerful, flexible, and dynamic. Okay, then like why it is flexible? Because you don't need compile it. In the C, you have to code and then compile and then run. But in Python, you just code and run it. That's it. Why it is dynamic? Because you just have to use, you have to tell your browser, like, sorry, tell your C interpreter that what type of value you are storing inside a particular variable. But inside Python, you just name your variable and then assign a value. That's it. After that, Python 2 versus Python 3. So there's some type of syntax differences as well as some libraries and frameworks differences. That's it. Like where you use Python, you can use it everywhere because it is general purpose. Okay, history of Python and violent Python and where is Python used? And the most popular libraries of Python. Okay, in the softwares we are going to use is Python 3 and VS Code. Now with the Python 3, you have to confirm that pip is installed or not. Okay, pip installed or not. So pip is a package manager of Python. Okay, which is used to install. Okay, so which is used to install the libraries and the frameworks. External libraries and frameworks. Okay. So you have to make sure that pip is installed or not. As I said that Python has many libraries and features like frameworks. Some are pre-installed, some are internally installed, or some are you have to install it externally. So for installing that packages or that libraries externally, you need a pip. Pip is a package manager for Python who manages all the packages of the Python. So for ensuring that pip is installed or not, so you have to open your CMD again and you have to type pip hyphen version. It's pip hyphen b. Sorry. So this is the pip. This is the version of pip. Okay. So now the installation process is clear. Python has been installed successfully. IDE's VS Code that you are going to use is installed successfully, and the pip manager is installed. Okay, there is not any like external process of installing pip. When you install your Python, it is pre-installed. It will come pre-installed with Python. Okay, so first you have to ensure that if the pip is successfully installed or not. So you have to just open the CMD and type pip hyphen v. That's it. Okay, there's no any like external installation process or pip. Now, so this is the intro part of Python. Now we will discuss the variables. Then we will move to fundamentals. So basically, what are variables? Variables are the container where you store a value. So variables are the container where you store the values. Suppose A equal 10 or B is equal to 11. So here 10 is a value, equal is an assignment operator, and A is a variable. So we are assigning 10 value to A. Here in the 11, we are assigning 11 value to B. Okay, so these are the values, like variables are the container where you store your values. Okay, so now let's see the example. Cross this. Yeah. So here you have to write A equal. Let me zoom this. Yeah. 10. B 11. Print A and print B. Just the basic code. So we have assigned 10 value to A and 11 value to B. And we are printing A and B. So the values will print. And when you click on the run here, click on here. So we are 10 and 11. Okay. So here A is 10, like we are assigning a 10 value to A and 11 to B. So print A, print B. Now let's see, let's see if 8 D is equal to let's say 30. So print C and print B. Run this. Okay, so we have all the values here. So variables are the containers that are storing the values. So 10 is a value and A is a variable. Now, there are some rules of naming the variables. Like you cannot name your variable anything. Suppose here A is a variable and 10. Suppose you want to name your variable something else. Let's say you are naming your variable print is equal to 10. Okay, so here print is a function. Let me write it. So print is a predefined function in Python. Okay, so it is a predefined function in Python which is used to print something or which is used to display something. Now, here print is a predefined function, and your Python interpreter knows that print is my function. No one can use it. So this is your responsibility that you cannot name any function or anything like predefined words as a variable name. Okay, so this will give you an error. When you run this, see, remove this, and when you print is equal to let's say 10. And when you are printing, okay, because print is the only function which is used to print something or display something. So they print here only and print the name of a variable. Click on save and run this. See, this will give an error. Okay, so you have to make sure that you cannot use a word or you cannot use anything as a variable name. This will give you an error. Now, print is a reservoir. So this is known as the reservoir of file. So, so we have some naming conventions. Okay, so we have naming conventions. Like you cannot name anything to your like variable, and so there are some variable rules that you have to follow, and that is known as the naming conventions. So you can put here variables rules or rules for naming variables. Okay. So what are the rules of naming the variable? The first rule is you cannot use reserved word. So you cannot use reserved word as a variable name. Okay, so you cannot use a reserved word as a variable name. Like reserved words are like print is a reserved word which have a special meaning to a Python interpreter. So like print, if else, elif, for loop, while loop, these are the reserved words, like the special words, which is also known as keywords. Okay, so they have the special meaning for the Python interpreter. So when you are naming here, print 0 to 10. So Python interpreter gets confused that print is my function and this user is using my function as a variable name. So this will throw an error. So Python will not accept this. Okay, so Python will not tolerate it. So you have to remember that you cannot use Python reserved words as a variable name. Okay, so this is your first rule. Second rule, your variable name should not start with a number. Okay, so your variable name should not start with a number. Like, for example, you cannot put like this, like one number is equal to 10. Print one number. So this will throw an error. Okay, because you cannot start a variable name with a number. But you can use number in middle or the last. You can use numbers in the middle or last. Okay. Now, third rule, spaces are not allowed. Like you cannot use space in like while naming a variable. Let's say first you are using first space name is equal to let's say John. So first name it is a variable, but there is a space. So this will give you an error. Like when you print it, print first name. For this, see invalid syntax. So spaces are not allowed, but you can use underscore in place of spaces. So we can write, but you can use underscore in place of spaces. If you want to use spaces, then you can use underscore. Underscore is like this one. Okay. So here you can put underscore. And here to one first name. Like when we read. So we have John. Okay. Fourth. Special characters are not allowed. Like special characters are like exclamation mark, at the rate, hash, dollar, percent, this one, etc. Okay, so these are the special characters. You cannot use special character as a variable name. Okay, like for example, suppose you are writing first name. Let's say someone writes user, or let's say first name, like this. So this will throw an error. Like you cannot use special symbols, like special characters inside your username, like inside your variable name. Either not on the like neither on the first character or not like in the middle or at the last. So you cannot use special characters like anywhere in the variable name. So they are highly prohibited. So make sure that you cannot use special characters. So these are some basic rules of naming the variable. Just the basics. Fifth rule, I'm adding it from my side. That is always name the variable according to your value. That your story. Okay, so always name your variable according to your value that you are storing. Suppose you are storing an age, okay, of a user. Let's say you are storing 18. Okay, 18 is a age, and you are storing inside a variable age. And you are naming the same variable a is equal to 18. So what is more comfortable to read? Age or a? What is more comfortable? Basically age, because when you are like coding or someone's come or like someone's come video code, some of your friend comes and video code. So age, so like they can easily understand, okay, age is a variable which is definitely storing someone's age. But when you see this a is a variable which is containing some type of value, not specifically age. So you have to remember this, that always name the variable according to the value you are storing. Okay, suppose you are storing someone's name. Let's say first name. So John. Okay. So first name is a variable and John is a value. So John is assigned inside first name. So like if someone's come and read your code, okay, first name it is a name. Okay, it is someone's name. But same time you are putting A is equal to John. So this is like how to read. Like no one can understand, okay, John is a name, but A is like maybe it is not look good. Okay, so you have to make sure that while naming a variable, you have to name your variable according to your value that you are storing. Okay, so these are the basic rules you have to follow while naming your variables. First, you cannot use reserved words as a variable name. Now, what are the reserved words? Let me mention here. Print, if, else, elif, follow, and while, and, or, not. Okay, in, not in, is not, etc. So we have many words. These are words. Okay, so you cannot use it as a variable name, or your variable name should not start with a number, but you can use numbers in the middle or at last. Okay, so and spaces are not allowed. You can use underscore in place of spaces. Places, place of spaces. Then special characters are not allowed. So these are special characters that are not allowed anywhere in the variable name, neither on the first nor on the last. And five, always name your variable according to your value that you are storing. For example, if you're storing anyone's name, then name. If you are storing the last name, then last name. Okay, so it's like it will make your code looks more good. Okay. So you have to make sure, like while naming the variables. So these are the name conventions you have to follow. You have to highly follow, otherwise it will throw an error. Okay. So these are the rules. So let's see some examples. Valid examples. First, first name. It is a valid variable. John. First name. Space name. This is invalid. This is invalid. So you can put here invalid. It is valid. Then one num 10. But num 1 is equal to 10. So this is valid. Let me write it here. It is invalid. Then print is equal to, let's say, 10. This is invalid. But you can put print underscore 1. That is valid. Okay, so you have to make sure while naming a variable, invalid or valid. And user, let's say, name. This is invalid. And name is valid. Okay, so remember the points, the naming conventions, the rules for naming the variables. So we have 5 basic rules you have to follow while naming the variables. If you not follow the rules, this will throw an error. Okay, like if you run this, see, if you run this will throw an error. Save your code. Okay, syntax error. Because you cannot start your number like variable name with a number. This is also an error, and this is also, and this is two. Okay. So you have to make sure that while naming a variable, and always name a variable according to your value that you are storing. And reserved words are not allowed as a variable name. That is the first point you have to remember. And the reserved words are the keywords, which are like have a special meaning in the Python dictionary. So you have to make sure that. Okay. So I think it is enough for today. So we have completed the intro part of Python, like why Python is useful, why we learn Python, and where we can use Python, why Python is a general purpose, installation process of Python, like how to install Python in VS Code, the IDE, and the variables, what are the variables, and the naming conventions of the variables. Okay. Now, if you want to see the course content of Python that we are going to cover, that so you can go to the website JNtech Networks. Click on the website, the official website. There you can Python. If you want to see the course content, the core modules we are going to cover in the advanced modules. So these are the modules that we are going to cover in the Python sessions in the core and as well as in the advanced. Okay. So here's a fee structure in the upcoming batches you can see this and the duration of the advanced course and the core Python. And then if you have any queries, like if you have any notes or the inquiry, so you can call on this number. Okay, so both the numbers are available, or you can mail on this number, or you can WhatsApp, or you can fill the inquiry form here. Okay, click on submit. Okay, so if you have any query, like feel free to ask. Okay, so thank you so much. We will now continue in the next session. Everyone, have this side. So previously we had discussed about the fundamentals, like the intro part of Python, and now today we are going to discuss data types as well as variables, more of variables, and we will see some fundamentals part. Okay. So if you haven't seen that video, that yesterday videos, then you can go to, you can search for the channel name, that is G2 Jaswal. Okay. So from here, you have to go to live, and then there's will be a channel like a video day one. Okay, you have to click on here, and then from here you can see the day one live video. I mean, it was live previously, like yesterday. Okay, so from here in this video we have discussed about the intro part of Python, like how to use Python, like how to install it, and then how to install the IDE of Python, as well as where, like why we use Python, and where we can use Python, who can use Python, like who can enroll in the course of Python, and how many types of Python we have, Python core and advanced. So in that session we have discussed it. So now today we will discuss data types as well as variables. So yesterday we had seen the variables rules, that is known as naming conventions. Okay. So naming conventions are like rules of naming a variable. Like you cannot like put any name to a variable. You cannot give any name to a variable. So we have discussed that. Let's revise that. First rule is reserved words are not allowed. Second, special characters are not allowed. Okay. And special characters are like exclamation mark, at the rate, hash, dollar, etc. etc. These are the special characters. They are not allowed inside the variable. Third is the variable name should not start with a number. So the variable name should not start with a number. Fourth, but you can like use number in the middle and in the last. Fourth, spaces are not allowed. And fifth, always name the variable according to the value. Okay, so these are the naming conventions, like rules of naming a variable that we have discussed yesterday. So now we will discuss data types. What are data types? So basically, data types are the value that you are storing inside any variable. Just okay, so we can write data types are the values that you are storing inside the variable. Okay, so basically, data types are the values that you are storing inside the variable. Let's say A is equal to V is equal to 10.2. So here A is an integer value and 10.2 is a float value. So these are the data types. Now we have many types of data types in Python. First we have string. Okay, so what are strings? Any character or group of characters, we can put it. Any character or group of characters that are enclosed inside single, double, and triple quotations. Okay, so these are the strings. For example, A is equal to hello world. Just strings. So hello world. Or we can say that hello world. Or else we can say that hello world. Okay, so these are the strings. Any character, like or group of characters that are enclosed inside single quotations, double quotations, and triple quotations. Now these are the alphabets basically. Now any character, like even number, though they are also the characters. Now they are strings, not number. This is number for us, but they are string in the perspective or in the eyes of the Python interpreter. Okay, so we have first string and then we have numbers. Inside number, we have three types of data types further. Like we have int, which is known as integer, short for int, float, no short form, just float, and complex, no short form, just complex. Okay, so we can write complex numbers, we can write float numbers, as well as we can write integer numbers. Okay, now what are integer numbers? Non-decimal numbers are known as integer numbers. Simple, like any number other than decimal numbers. Float numbers, we can write here non-decimal numbers. Float numbers, we have so these are the floating point number, which are decimal numbers. So every decimal numbers are the part of the float numbers. Then we have complex numbers. Inside complex number, it is like the combination of real and imaginary number. For example, 1 E. So 1 is a real number and E is an imaginary number. Okay, so these are the numbers. Then we have Boolean, which is known as Boolean value, short for Boolean. Okay, Boolean. In this we have true. In this we have false. Only two values, true and false. Okay, so we have true and we false. Yes or no? Basically true or false. Okay, and whenever you are going to use the Boolean values inside of Python, you have to put true of T capital and false of F capital. Okay, always use uppercase for T or F. Okay, you cannot put true like this because T is in lowercase. So remember, whenever you are using the Boolean values inside Python, you have to put true like this. Okay, T should be capital. Same as false should be caps in uppercase. Okay. So these are the very basics data types. So let's see the practical. So I'm making a file here. Yeah. File.py. Yes. Okay, no. Let's change the name. File. Let's say data types.py. Okay. So open this file in the VS Code. Now here, so we have strings. So we have strings. In the numbers, we have integer values. We have float values, and then we have complex values, as well as we have boolean values. So for the strings, create a variable. Let's say a, or we can put first underscore name. Okay, so spaces are not allowed. Remember? No. Here you have to use John. Okay, so John is a string here, and first name is a variable. So we are assigning a name or a value to a variable. So this is known as data type. Okay, this value is known as data type because you are storing a value inside a variable. Okay, so let's print the first underscore name. So run the program. So we have John. Okay, let's do the same for last name. Let's say any last name. Sky. Bunny. Okay, so we can put here, we can print the last name. Save it. Okay, so we have done Sky. Okay, now let's merge them together. So first name, comma, last name. Okay, so we are merging them. So we have John and Sky. See, we have a space in between. Okay, so you can merge them together by following the comma, or you can use the plus operator here. Okay, so here we are using plus operator. So print it. John is Sky. Now we don't have any space here. Okay, so basically, this process is known as concatenation. Concatenation. What is concatenation? Concatenation is like merging the two strings together. So we can write here. This is a, which means merging or adding. We can write adding two strings, only strings, not numbers. Two strings together. So we have the first name as John. Okay, it is a string, or Sky, it is also a string. So we are merging them together with the help of a plus operator. And this is known as concatenation. Okay, now what about space? When you run the program, so see, we don't have any space. So you can either put space here and then run it. Okay, so we have John Sky, or you can space here before the Sky, or you can add space here with the plus operator. John Sky. Okay, now you cannot add, like you cannot do like this. You are just using the first name and space for last name. Or here you are spacing. Okay, this is not a valid way, or Python will not add a space here because it is just a space. And this is like Python has no meaning for this empty space. When you run the program, it will select join describe. Okay, so if you want to add space or if you want to add anything like any letter, any number, you have to use string. Okay, so let's put here space. Only one space. Irrespective of we have many spaces here, just we have one space here. Okay. So John is only one space. And multiple space here as well. So remove this space here. This one space. Then we have many spaces here. John and Sky. Okay, so this is like you have to put spaces in the quotations also. Okay, you cannot put spaces like this. Okay, this is like Python will not understand this. Okay, so Python can only understand whatever you are writing inside quotations. Okay, suppose you are writing, let's say you are printing something. Print hello world. Okay, so this will throw an error. When you run this, we have this error, invalid syntax. Perhaps you forget a comma. So basically, Python will not understand anything like this. Like you are writing without quotations. So whatever you are using, whatever you are writing, you have to use the quotations. It is compulsory, either single or double. So we are running this. Hello. Okay. So remember quotations. And when you are using quotations, they are known as the strings. Okay, so basically you are using strings. And string can be enclosed inside single quotations, double quotations, and triple quotations. Then we have numbers. Inside numbers, we have int, means integers values, float numbers, and complex numbers. So let's see the example. Before that, check the type of the variable type of first one. Okay, so this is a type function. Let me write this here. We have a type function. Okay, so type function means it will tell you, we can write. Okay, so type function will tell you the type of value you are storing inside any variable. Okay, any variable. So basically we have type function. So type and first name. You have to put a variable name inside that type. Okay, and then run this. So John is a string. When you run this is a string, short for str. Okay, so we can write here str. Okay, so type function is like we tell you the type of value you are storing inside any variable. So we have to type and the type of value you are storing, like the variable name. Okay, so the variable first name is storing the string value, class this string. Okay, now let's create another variable. Let's say num1. Okay, is equal to 10. Num2. Okay, now let's run this. Print number. Okay, so we're using the print function as well as we are printing num1, num2, and num3. The values of the variables. So the values of num is 10, the value of num2 is 12.3, and the value of num3 is this one, 1 plus 2j. So here 1 is the real number and j is the imaginary number. Okay, so we rarely use the complex number inside Python. We only use the float as well as the integer in the day-to-day program. So here we have num and num1. See, remember when you are printing the variable name, num1 is a variable and you have the value 10. But and num1 is a variable here. And when you put num1 inside a quotation, as I said, you have to put everything inside quotation. So when you run this inside quotations, see, we have num1 as it is. This means now num1 is a variable string here, not a variable anymore. Okay, so you are printing string, and when you print string, so the string will print as it is. So we are number, not the value of the number, but that is 10. So whenever we have a variable like number is a variable, okay, number is a variable that is holding a value 10, and you are printing the value of the variable that is number 10. Okay. Now suppose there is no variable named number, and that will give you an error because and the error is number is not defined. Let me run it this. See, number is not defined. Did you mean number? No, number only. So name number is not defined. So basically you will write number 12, anything like that. So number, number, and number 3. So remember, whenever you are using the variable, you have to put just like this only, not with inside quotations. Because number is a variable, not a string. And whenever you put a string, okay, then this will become a string and number will print as it is. Okay, even you cannot do like like this. This is a double quotation, and you are using single quotation here. This will give you an error because Python will not understand this. Okay, what is this? Save the code and then run this. Okay, syntax error. So you have to put the double quotation here. Okay, so this is how you have to do this. Now basically, like number, here we have right quotations, number, and we have to use double quotation only. Like we will use colon, we will use parenthesis, we will use curly braces in the like in the functions, etc., in the loops. But why we are using these colon, parenthesis, like round brackets or curly braces or the quotations inside Python? As you said, as I said, that Python is easy to understand, and still I am making it complex because this is the syntax of the Python. This is how Python is. Okay, so quotations and colon, like putting the quotations, colons, and the like curly braces is the grammar of Python. Okay, and you have to follow the rules of any language, and that is the this is the grammar of Python. Like whenever you write a sentence, let's say Python. Python is a powerful language. Full stop. Okay, so whenever you write in English, P should be capital, etc., and you use full stop. So this is the grammar of the English, same as where the grammar of the Python. By following the quotations, by following the that colons, round brackets, parentheses, or curly braces, or any type of like special characters. So basically, this is the grammar of Python, and you have to use it. So we have number, and remove this colons and run this. We have these. Okay, now let's check the type of value the variable are storing. Type and then number. Same as the type inside number. Type. Okay, so number. So number is integer, num2 is float, and num3 is complex. When you run the code, we have class int, float, and complex. This is integer value, float value, and complex value. Okay. Now let's see the Boolean values. So let's say anything A, true. Yeah, true. B, print A, and print B, and then print the type of A. Type of A, and print B, type of B. When run this, see we have true and false as it is, and then we have bool and bool. Like true and false are the Boolean values. So here, print A and print B are the variables, like A and B are the variables, and true and false are the Boolean values. That is why we have class bool, like short for bool. Okay. So here when you see when you put T in small and F in small, okay, when you run this, see we have a name error. True is not defined. Did you mean true? Yeah, we mean. Okay. So basically we have to use true like this. T should be capital and F should be in uppercase. Then you can run this. Okay. And if you want to use it true, like if you want to use true as true only, like small case, then you have to put quotations. Okay, then this will not throw any error. And when you run this, so here, see, true and false are not like are not the Boolean values anymore. They are the strings now. Okay, so true and false are the strings, not the Boolean anymore. So remember when you're putting quotations anywhere, you have to just use print A, like T should be capital and F should be capital. Let's put false here. Okay, now they are the Boolean values. Remember this one. Okay, this is very important. So these are the data types we have. Now we have many data types for the. Okay, so we have the string, numbers, and booleans. Now next we have list. we have tuples, we have dictionaries, and then we have set. Okay, these are the main data types we have. Basically, they are known as sequential data types because they are in sequence. Okay, so before that, let me show you one more thing. Suppose you are assigning a variable, let's say a, let's say num1 is equal to 10. So you are storing 10 inside num1. Let's put another value here, 20. And when you print num1, so this will throw an error. Basically, this is a tuple, not a like, but you cannot put this like this. This is not a string. Now this is a, when you print this, you like type of num1. See, this is a tuple. When because we are storing this is a number basically 10 and 20 is an integer. Like when you print num2 is equal to 10 and print type of num. Okay, so this is an int. And basically, if we cannot store multiple values to a single variable like this, basically, because now this becomes a tuple, and tuple is another data type. Okay, now if you want to assign 10 to one variable and 20 to another variable, then you can put num2 here. Okay, now number one, 10 is storing 10 is inside number and 20 is inside variable number 2. And when you print it, remove this line, check it now. This is an integer value now. And when you print the type of num2, print the type of num2. This is the integers. Okay. So you have to remember if you are storing different values to a variable, then you have to put the equal number of variable names as well as the equal number of values. Okay, so this is just now. What if you want to store multiple values to a single variable only, like this we are doing num1, or let's say okay, suppose these are three values, and you want to store inside A. Then we have to put another variable name like B and C2. Now apple is inside A, cherry is inside B, and oranges are inside C. So what if we want to use only single variable and we have to define multiple values? And that is why we use list, tuple, dictionary, and set. That is why they are known as sequence data types. Now what are lists? So lists are the, let me draw this here. So basically list underscore one. Okay, you cannot put list as a variable name like list is equal to, this will throw an error because list is a reservoir. So list underscore one, square brackets, and then apple, cherry, oranges, and then print the list underscore one, and then print the type of value. The list one is storing. Okay. See, list one is storing. First, we have the list one as it is, and then we have the type one is list. So this is known as list. So multiple characters like see apple, cherry, and oranges. These are known as elements of the list. So apples are an element, cherry is another element, and oranges is another element. So these are the elements of a list. So anything inside the square brackets are known as list. Okay, like multiple data types you are storing. So these are known as list. Okay. Then we have tuples. We have raised and we have tuples underscore one. They are inside round brackets, that is parentheses. Okay, let's put the elements here. When you do this, so first we have a list exactly with the tuples, and you can see tuples. Now, what is the difference in list tuples as they are storing the same number of elements inside a single variable? Okay, for example, like basically first point that you can like store any number of elements. Like you can these are the elements. We have currently three elements inside list. Like you can like store many elements. Like you can store 100 elements, 1,000 elements, like many elements inside list as well as inside tuple also. But now what is the difference in list and tuple? If you can store any number of elements inside both. So basically for that we will see later. Like basically there's a concept of mutable and immutable. Okay, mutable means changeable. Means you can easily change it. And immutable means unchangeable. Okay, so lists are mutable in nature or tuples are immutable in nature. Okay, so we can write here lists are changeable. Sorry, we can write here mutable. And tuples are immutable in nature. This is only the one difference, like we have many differences in the list and tuple. Okay, this is like the very important in the basic difference. List are immutable means we can change the list and tuples are immutable. Now, what is the means of changing here? See, we have list here the apples, cherry, and oranges inside list. These are the elements. Apple is the element, cherry is the element, oranges is the element. Now you can change the value of the elements. Like you can put you can put grapes in place of apple. You can put cherry, like you can change the cherry value to any other value. You can put numbers in place of oranges. Okay, so you can put like you can change the values of the elements. Okay, you can add many values and you can remove any values. Okay, so we have three factors. We can modify the list, we can add values, and then we can remove values. So we can modify, we can add values, and then we can remove values. Add means we can you can add more elements. Like once you have created the list, after that, like if for example, if you have to add multiple values, like more values inside list underscore one, then you can easily add it without touching this list. Okay, like without rendering this list. Once you have created, you can add values, you can even remove the values. Okay, like if you want to remove this, you can easily remove this. Removing doesn't mean that you are removing from here. No. Removing means you are creating another, like you are using the remove method or remove function of the list that we will see later. That is known as list manipulation that we will see later. Okay, so remember, removing doesn't mean that you are removing from here. Anyone can do this. Even you can do this in the table also. But removing means you are using the remove or clear functions of the list. Like once you have created the list, now you have not to touch the list. Just you have created, now you can remove the values, you can add the values, or you can modify the values without touching this list. Okay, this is why lists are immutable in nature. Because they're immutable in nature because you cannot modify it, you cannot add values, you cannot remove values. Like you cannot do anything. Okay, inside tuples you cannot add values, like you cannot add many more values, you cannot remove any values, and you cannot modify any values. That's why we have tuples. Now we have to use list and we have to use tuples that we will see later. Okay. Every data type has its own specific needs. This is list and tuples. Now we have dictionaries. Dictionaries are known as key values pair. Okay, so we can write right here. They are known as key value pairs. And data inside is curly braces. Okay, they are mutable in nature. Yeah, they are mutable in nature. You can add values, you can remove values, you can change the values in the dictionaries. Now, how to create? Let's create a variable dictionary underscore. And then first we have to put key. Let's say A is a key. Name is a key, colon, and the value here. John is a value. Comma. Age. Colon. Value. Okay, so name is a key and John is a value. and they are separated by a comma colon. So this is first key value pair, means one key value pair. And this is another key value pair, like second key value pair. So you can add many values as you can, like any any pairs, any number of pairs. And key value number one and key value number two are separated by comma. And the key and the value, they are separated by a column. So remember this. Okay, now so this is a dictionary. When you print a dictionary, they are basically in a JSON format. Okay, dictionary underscore one and print type of dictionary. Run this. So after running, we have the name and then we will join. This is the dictionary as it is, and then the class is dictionary. This type of dictionary type data type is dictionary. So this is dictionary. Now we have said. Okay, so dictionary are mutable in nature. Like you can add many values, many pairs. You can remove any number of pair, or you can modify the values of the keys inside dictionary. Now set are both mutable and immutable in nature. How is it possible even? And they are inside curly braces. Now why set are mutable and immutable both in nature? Why? Let's create a set here. So set underscore one curly braces. Let's say apple. We have cherry and then oranges. Let's print the set underscore one and print the type of set underscore one. You cannot use set as a variable name because this is a like reserved word of Python. That is why I am putting set underscore one, additional underscore one, tuple underscore one, because you cannot put tuple as it is because it is a reserved word. The naming convention says that you cannot put the variable name as a reserved words. Run this. See, this is the set and this is class set. Now the question is why set is mutable and immutable in nature both? See, apple, cherry, and oranges are the elements of the set. So the elements of the set are immutable in nature and the set itself is mutable in nature. Let me write it. So elements of the set are immutable in nature. But set itself is mutable in nature. Not name, nature. Okay, means this is the nature of the set. Like now, why it is mutable, immutable, we don't know. Like it is pre-programmed. So set is mutable and immutable because apple, cherry, these are the elements. You cannot change the values of the elements. Like you cannot change the elements value here. Oranges, you cannot change it with another value. Grapes, you cannot change apple value with banana. So these are the elements. You cannot modify the set, but you can add or remove the values. Okay, so we cannot elements of the set are immutable in nature because we can write because they are because you can modify the set elements. Sorry, but you cannot modify it. You cannot modify the set elements. Modify means you cannot change the value, and set means here you can because you can add or remove the elements of the set. Okay, so that is why set is mutable and immutable both. Like you cannot change the values, the elements values inside set, but you can add or you can remove the values. Okay, now see, this is the nature of the set. Set is like fully immutable and immutable. But that is why we have frozen set. Frozen set means it is used to create It is used to create set fully immutable in nature. Okay, that is why we have frozen set. Frozen set is used to create fully a set of fully frozen set underscore one. We have to use a frozen set constructor here. Frozen set and then set underscore one. So frozen set have no doesn't follow any format they are inside the libreaces. No, they are just frozen set. So frozen set are used to create your set fully immutable. So when you print set underscore two and when you check the type of set, in this so sorry, frozen set. Frozen set underscore one. When you run this, so get frozen set, apple, these are frozen set, and then class frozen set. The frozen set is fully immutable in nature. Like you cannot add values, you cannot remove values, you cannot modify the elements of the set. That is why we have fully like frozen set. We just used to make a set a fully immutable because set is mutable and immutable both. Okay, so that's why we use set like frozen set to make it, to create it, or to set it fully immutable. Okay. Now some points to remember. You can add any data type inside data types. Like we have list underscore one. So here in this we have strings. Okay, so list containing strings. Apple, cherry, oranges are string. Now you can add any values or any data types value. Like you can add integers, you can add float, you can add complex number, even you can add list inside list. You can add dictionary inside list, you can add tuples inside list. Okay. So you can add boolean values. So okay, so this is a list. Inside list we have another list. And inside list we have the numbers integer and then we have strings. And when you run the program, okay, so we have this list, class list. So this is the flexibility of the programs like data types, list, tuples, dictionary, set, and frozen set. There, they can store any type of data type inside this. So we can put here a point note list. We have tuples, we have dictionaries, and then we have set. We can mention frozen set, but okay. List, tuple, dictionary, set are can store any data type values. Okay, whether it is int, float, dictionary, or complex or boolean values. Same as with the tuples, same with dictionaries, same as with set. Our dictionary can store dictionary also. Our tuple can store tuple also. Our tuple can store dictionary also. Okay, so you can store any type of data type inside list, tuples, dictionary, and set because they are flexible in nature. Now dictionaries are mutable in nature, frozen set are immutable, and set are immutable both. So they are immutable in nature. Okay, so that's enough for today. We have discussed all the data types, like we have list, tuples, dictionary, set, frozen set, integer, and float, complex, and strings. Okay, so these are the most important, and these are the only data types in Python. Okay. Now, if you want to see the course content of the Python, like what are the modules we are going to cover, then you can go to JNtech Networks, the official website. From here, you can click on the Python. Scroll now. Here you can see all the modules that we are going to cover in the upcoming sessions. Okay, like the core Python and advanced Python. Then we have the fee structure here listed here and the upcoming batches and the duration of the courses. You can see from here. And still, if you have any inquiry, you can call on this number. Both the numbers are available, or you can WhatsApp, or you can mail on the number, or you can fill the query form and click on submit. Okay. So if you have any queries or if you have any doubt or a technical doubt, you can comment. Okay. So I will answer that side. So this is the session number third of Python day 3 in English. So basically, previously we have discussed fundamentals like the intro part of Python, how to install Python. Now in this session, we will see the fundamentals part like what are tokens, equals, identifiers, etc. So before that, if you haven't seen that video like previous videos, you can go to the YouTube channel. You can search for the channel name. Okay, so from here, you can search for the channel name that is JNtech. Okay, from here, you can see the previous video of day 2 and day 1 of Python in English. Okay. So this is day 2 series. You can right click and open it, new tab, and day 1 series. Okay. So let's start series. I will use 1 to first to see these videos, and you can move forward to the day 3 video. Okay, or day 3 session. In day 1, we will discuss the intro part, what is system, how to install passes, the software that we are going to use in Python. Okay. And the day 1 series, in the day 2, we have discussed the data types and variables, like name conventions, is used for names the like different types of data types. Okay. Now in this session, we will discuss the fundamentals. So we will discuss the Python fundamentals as well as the operators. Okay, so Python fundamentals. Inside Python fundamentals, we have tokens, identifiers. So we have tokens, we have identifiers. Okay, so basically, what are tokens? Tokens are the smallest unit in Python. So tokens are the smallest unit in Python. Okay, basically tokens means smallest unit. Yeah, basically the tokens means every small value, everything in Python is a token. Okay, let's see whatever you see the variables, the characters, the operators, everything in Python is a token. Okay, basically those have like special names like we have variables, we have characters, we have numbers, we have integer values, float values, but at the base level, everything is a token. Okay, so tokens are the smallest values in Python. They are the smallest individual values in Python program. Okay, like all the statements, instructions in Python are built with tokens. Okay, like we have the reserved words, we have the if statement, else statement, else, elif, or true false value, data types, variable names, function names, all are the tokens. Okay, so we can write here tokens are the smallest individual value in individual unit in Python. Okay, so now what are identifiers? Identifiers are the names given to some variables or some functions or some classes. Okay, means whatever the names given by the user in the Python program are known as identifiers. See, when we have the identifiers, like first one we have the name that is given by the user, and second are the names which is used by the Python itself that are known as reserved words. Okay, so we can say that identifiers are the names that are given by the user. Okay, are the names that is given by the users. Now given to functions, that variables and classes. Okay, etc. So they are the names that is given by the users to the, we can write here, functions, classes, and variables, okay, etc. That is known as identifiers. Okay, then we have the keywords. Keywords are the special reserved words for Python, okay, which have the special meaning for the Python interpreter. So we can write keywords are the reserved words, special reserved words for of Python. Okay, which have a special meaning, a very special meaning to the Python interpreter. Okay, that is known as keywords. For example, we can write if, we have the else, we have elif, we have print, and we have or, and, in, not in, or we can write not. Okay, we have for, we have while, etc. Okay, like there are many reserved words which have the special meaning for the Python interpreter. Like they are the reserved words and they are listed in the Python dictionaries. Like not that dictionary, not that data type dictionary. It's like the special dictionary of Python. We cannot use these names as your own use. Okay, like these are the reserved words, and you cannot make use of it. Like you cannot name it as a variable, you cannot name it as a function, or you cannot name it as a class, or you cannot name it anywhere for your own purpose. They are the special words. You can only use them what they are made of. Okay, like print is a function which is used to print something. So you can only use the print function to display or to display the output of something. That is known as keywords. Okay, now this is identifiers. Now, in the identifiers, we have like many identifiers. No, this identifier. Yeah. We have the literals. Sorry. Basically, they are also come under identifiers, but they are literals also. Literals are like they are the special, like they are the basically part of the identifiers. Okay, inside literals, we have literals are basically like the data types. Okay, so we can put here like literals are the part of the data types. Like we have many literals. We have the string literals. We have the numbers. Inside numbers, we have the integer. We have the float, and we have the complex. Okay, and we have the boolean literals. We have the list. We have the tuples, etc. So basically, literals are just nothing. They are just like the data types. Okay, so we can just leave this as it is. So literals are just the data types. Basically, data types are like the data types. They come in the inside category of the data type, but they are also called literals sometimes. I don't know why the Python like made these difference, but data types are the data types. Like for example, data types, but data types are also known as the literals. Inside data types, we have the string, we have the int. Inside numbers, we have the int, integer, we have the float, we have the complex, and then we have the boolean values, then we have the list, tuple, dictionary, set, and frozen set. And same as we have the literals, we have the string literals, with the number literals, we have the inside number, we have the integer, float, and complex. Okay, so and rest are these are like fundamentals. These are the basic part of Python. Basically, we know about the keywords, and literals are known as slide data types, and identifiers are known as the names that is given by the user to any value, any functions, classes, or in variables and tokens. Okay, they are just the fundamentals of Python. So, like these are the terms you can use, like you can like find it and everywhere. So that is why I just cleared it to you. Okay. Now data types we have already discussed. What are data types? String are the ones, any character that are inside single quotations, double quotation, and triple quotations. Numbers, integer, float, and complex. Integer are the non-decimal numbers, float are the decimal numbers, and complex are the combination of real and imaginary number. Boolean values, they are like they are like the they includes two values, true and false. Okay, list, they enclose inside square brackets, which is mutable in nature. I'll put comma here. Doubles, they are inside the round brackets, which are immutable in nature. Okay, then we have the dictionaries, which are inside curly braces. They are also known as the key value pairs, which are mutable in nature. Then we have the set, they are inside curly braces, which is immutable and mutable both in nature. And why it is so? Why set are mutable and immutable both? That we have already discussed in the previous sessions. And what is mutable, immutable, that we have already discussed. So we are not going in deep. That frozen set, they are immutable in nature. Okay. So these are the fundamentals of Python. Now let's discuss the input and output function in Python. Before that, we have the input and then we have the output function in Python. Basically, input means whenever you are taking the input from the user. Okay. Like whenever you are taking, suppose we have created a calculator or you have created a form. So inside that form, you are asking for from the user, please enter your name and please enter your roll number or whatever. Please enter your last name, your name, etc. So this is known as taking input from the user. So whenever you are creating a program, you want to make it flexible. Like whenever you are creating any program, you want the user to input anything inside your program so that you can display the output out of this. So we have the input function for that. Input is like taking input from the user. And now how to take an input from the user? We use int keyword for that. Int keyword, which is used for taking the input. Okay, so we will use, let's see in the Python interpreter. So I'm creating a file here, new file, and then name it. Let's say input underscore file dot py. Okay, yes. Open this inside your VS Code. Okay, oh my God. Okay, now let's say first name. First and the name equal int input. So the input enter your name. Print first name. Okay, so we use input. This is input, not int. Input. Okay, so I want to take the first name from the user. That is why I'm putting input and enter your name. Enter your name is a string here. Enter your name, you are writing this. This will display as it is. Okay, you are asking from the user, please enter your name. So you are writing enter your name. Okay, now when you run from this side, so might be you cannot able to write something here. So press stop. Okay, now go to the terminal here. Here, go to the location where you are, where your file is. So my file is in desktop. Oh, sorry, it's desktop. Now run your file. To run the file from the terminal, you have to write Python and the name of your file. So my name of my file is input file, input underscore file dot py. Enter, enter your name. Let's say Bhavya. Bhavya. So the name will be printed as it is. This is how you can take input from the user. Okay, now how to take multiple inputs. So let's say last name. No, I'm asking from the user that please enter your last name. Okay, so when you run the program, let's clear the screen. Yeah. Python input file. Okay, enter your name, let's say Bhavya. Your last name J. Sorry, we have to print this also. To print the last name also. No, we can run this now. Your first name Bhavya. Oh, okay, so your name is printed. It is Bhavya, your first name and last name. You can print it like you can print it together. When you remove this, you can just put last name here. Yeah. So we can put last underscore name. Okay. And when you run the program, okay, so you the John, and then it is. So this is printed. This is how you can take the input from the user. Now, like I'm as a developer, I'm just testing my program. That is why I am putting the name here. Like when you send this program or when you launch this program in some website or some in some like GitHub like platforms, then the user will able to input it. Okay. Like here I am the user and I am the developer. That is why and here I am testing my program. That is why I'm putting the my name or I am putting the input. But this program says that it is asking the input from the user. Okay, like the program is asking enter your name. Let's say your now the program is asking again to enter your last name. That is Sky. Okay, this is how you can take the input from the user. Now let's see the another example. Okay. Now let's take two numbers from the user. So num1 input, enter the first number. Num2 input, enter the second number. Enter the second number. And then print the number 1 plus num2. Number and num2 are the variables here, and these are input. Enter the first number, and so here we are asking from the user to enter the first number and enter the second number, so that we can perform the operation, that is addition operation. Okay, simple. So now let's clear the screen and run the program again. First number, see, whatever you write inside the parentheses, these are known as the parentheses or the round brackets, like enter the first number in the column here, this will be printed as it is. Okay. If you put enter the number, then the enter the number will be printed. But you are putting enter the first number, so enter the first number will be printed. So whatever you write inside this parenthesis, inside the quotation, this will be printed as it is. The first number is a 10, second number 20. And see, we have 10 and 20. Instead of 30, we have 10 and 20. Here, what we are doing, we are taking input from the user. First input is at 10. Second input, we have put 20. So, and we are adding the two operations, like we are adding the num1 and we are adding num2. So, if we add 10 plus 20, what will be the answer? 30. But instead of getting 30, we have 1020. Okay. So, what does this mean is here the Python is taking the numbers as a string, not as a number. As you know, everything that is inside quotations are the part of the strings. Okay, like here, what are strings? Like whatever you put inside the quotations are the strings. Whether they are the number, they are the characters, or they are the alphabets. So we are doing here 10 plus 20. So for Python, they are not numbers anymore. They are 1220, 1020. They are the just characters. They are the values, not the numbers. That is why just Python is concatenating each other. Like they are just putting or merging them each other instead of adding them. Okay. So what we have to do now, and why it is doing so? Because this input function always take input in the form of strings. Okay, so we can write here input function. We can write a note here, note. Input function always take input in the form of string. Okay, whether we put number, whether we put any character, whether we put anything, the Python, this input function will take everything in the form of string. So whenever we are putting 10 or 20, this number is 10 and 20. Means the Python or the input function convert that or just take the input in the form of string. That is why we have the answer 1020. Okay, now what we have to do is we have to convert the string into number. Then only we can have a addition operation. Okay, like we have to convert the string into the real number. That is, like we have to convert your string into numbers. So for that we will use the int or float. Int, or we can use the float. Int means integer and float means float. So just write int before that. Int, then input. Same as here, int, bracket, and bracket at last. Save it. That's it. And when you run the program again, clear the screen. Enter your first number, let's say 10 and 20. Now we have 30. Okay. Now what is it? What it is doing? The int is a keyword which is converting the string into numbers. Okay, you can even put float here. Float. Float means floating point number. When you put float here, and when you run the program again, sorry, stop from here. Just run it from here. So we have 10 and then we have, let's say, 11. So we have 21.0. So 0.0 is because of the float here. Float is decimal numbers. And when you put int here, like when you put integer, so your now string is converted into integer. Let's save it, clear the screen, run the program, 10, and then we have 11. It is 25. Okay, this is how you can convert your string into any, like into integer or a float. And this is known as typecasting. Okay, so this is known as typecasting. Typecasting or type conversion. We can write type conversion. Now, what is typecasting or type conversion? It is like changing your one data type to another. Okay, it is the process of changing your one data type to another. So that is known as typecasting. You are changing your string into integer or you are changing your string into float. Okay, that is why we are changing our one data type to another. Okay, that is why we have the previously input is taken the input in the form of string. Now when we put int here, we are just changing the string into integer values. Okay, this is one way. You can also write in this form. Like if you want to write it, you can like num1 equal input, enter the first number. Then we have num2 input, enter the second number. Then you can change the numbers, like you can use a is equal to int of num1 and b equals int of num2. And then you can print a plus b. And see, if you print num1 plus num2. So here, let me run the program. See, first number, let's say 10, second 11, enter. See, we are taking the input from the user inside variable num1 and num2. Okay, so we are putting input enter first number and enter the second number. So the user put 10 as the first number and 11 as the second number. Now in the line number 11, we are converting the the string into integer. That's why we have put int. We have called the integer function and we are converting the num1 into integer, and in the second variable b, we are converting the string into integer and num2. Okay, we have called the num2 inside the that b, inside b. Okay, so we have created a b variable at int and num2. We want to change the string type of string data type into integer of the variable number num2. Okay, then we are printing num1 plus num2. This is num1 plus num2. Num1 and num2 are the string here. Okay, so num1 and num2 are the string here. They are not the integer values. They are the string here. That is why when you just perform the addition operation, num1 and num2 answer is 10 or 11. Okay, but when you perform a and b, that is integer num1 and num2, the answer is 21, because now a and b are the string, sorry, integer values. They are the string integer values. Okay, because we have converted your string values into integer values in the variable number a and variable number b. And then we perform the addition operation on the a and b. And the answer of a and b is the integer. If you check the type of a and b, then you can easily check the type. That is another. Okay, this is how you can convert your string into integer, and you can even put float here. Like you can even create another variable float, and float is num1, and we can put d is equal to float num2. Now we can print here c plus d. See, previously num1 and num2 always remain the string. Okay, in the a and b we are converting it into integer. In the c and d we are converting the string into float number. When you run the program again, we have the, don't run from here, we just run it from here. First number, let's say 10, 2. Okay, so first we have put num1 plus num2. Num1 plus num2 are in that is string. So we have 102. 10 plus 2, 102. Then we convert it into integer. So we have 10 plus 2, 12. And then we have converted into float. We have 10, 12 plus 12.0. Okay, so this is how you can convert your input function into integers. If you are taking numbers only. And when you remove this, you can even do this like this. You can do this directly, like input int. We have put int before the input function. So you can do this like this also, or you can do this like this also. But what is more preferable? This one. Okay, I will prefer this because this is you can easily put int here and then input. Okay, because we have 3 lines of code, and here we have like around five lines of code. Okay, and when you run the program, this will terminal clear the screen. First number 4, real 9. Okay, so if you are taking input as like if you're taking number as an input from the user, then always put in here. Whether you are taking numbers, whether you are taking someone's age, or whether you are taking anything which is in the form of numbers, and you want to perform any operation on that, then you can use int here. Okay, you can put integer or float. Okay, whatever you like. And this is also known as typecasting, like changing your one data type from another. And what about output? Output is like nothing. It is like printing your output or displaying your output. And we can do this with the help of print function that we have already seen. Okay. So we can write here output means printing, or we can say this displaying the output on the screen. And we can do this with the help of print function. Okay, print function. Input is like taking input from the users. And input function always take input in the form of strings. Okay. Then we have typecasting. Typecasting means changing one data type to another. Now, what does it mean? You can change your string into integer, into float. You can change your float into string. You can change your like integer value into string. You can change your any data type from one data type to another. Like you can change your list into tuple. You can change your tuple into list. You can change your set into list, etc. So let's see. Suppose you have a string here. Let's remove this here. Suppose you have a string here. Let's say A is equal to 10. When you check the type of A, this is a string. Okay, when you run this, so this is a string. Okay, now let's change B is equal to. Now, if you want to change it in int, then you can change it in int. And if you want to change in float, you can easily change it to float. Let's print the type of data type. The C in the B variable is storing. Print type is, let us see. Okay, so first print A is a string here. So we have printed A. Type of A is string. Now in the B variable, we have converted your A string into integer. That is why we have A, B variable is a string here, and C is a float here. So C is a float here. This is how you can change it from one data type to another. Okay. Now, what if we have the string like this? We have, suppose we have apple. Okay. So we have the A apple. Okay. If you change this from one data type to another, like B is equal to int of A. So what will happen? Print the type of B. Type of B. See, here A is an apple and we are changing the apple into numbers. So when you run this program, this will throw an error. Because how is it possible that you are changing your apple, that is a combination of alphabets, into number, that is integer. So this will give you an error. So whenever you are changing your string into integer, you make sure that this is a number. String should be also a number. Like string characters is a number. Then only you can easily change it. Otherwise, when you try to change the string, like suppose we have this string apple, and whenever changing it from integer, and when you run this, we have this error. Okay. And let's say we have the 10 here, and when you run this, this will be easily be changed. Okay, because 10 is a number. Basically it is a number. Why? Because we can easily see it is a number, but for Python it is a string now. But so here we are changing the string into integer. But when you put any character, like any combination of character or any special character, so and you try to change it in string, or sorry, in integer or float, this will give an error. Okay, no, but suppose you have a number here, 10. Now you can easily change this number into string. You can easily do this. Print, we have A. B is a number. Okay, and A is a variable. In the A, B is a basically a integer value. Okay, and we are converting the integer into string by calling the str function. Okay, so run this. So here we can check the type of A here, type of A. When you run the program, give string. Okay, you can easily put here float also. Like, okay, so this is a float number now. Okay, so B is a variable in which we have a value for float. Okay, 10.88. Now A is another variable. Inside A, we are calling the string function, and inside string parenthesis, we have a B. Means we want to change the data type of the variable number B. That is why we have put B here. And then we are printing the type of A. Now the type of A is string because we have changed it to another. Now if you change, check here B, Okay, print type of B, then we are this is the float. Because inside the variable number B, we have the float here. Inside the variable number A, we are changing it. Okay, so but currently inside variable number B, we have the float. When you type A here, inside A, we are converted the float in string. That's we are string in. Okay, this is how you can change. These are like basic data types. Okay, you can easily change the list into tuple, tuple into list, etc. That we will see tomorrow. Okay. So tomorrow we will see the how to change the list into tuple, tuple into list, or set dictionary, etc. Okay, as well as we will see the operators. Okay, so if you want to, okay, if you want to see the content of the Python core advanced, like what are the modules we are going to cover, so you can go to the website JNtech Networks. From here you can go to Python. Okay, scroll down, and from here you can see the modules that we are going to cover in the entire sessions, like in the upcoming sessions. Like this is for the Python core and advanced. Okay, we will use the GUI libraries. We will use, or we will see the networking. We will see the networking libraries, etc. And the database libraries. That is MySQL. Okay, and if you want to see the fee structure, you can see from here, as well as if you want to see the duration of the course or the upcoming batches, you can see from here. If you have anybody, you can call on this number. You can call any of these numbers and you can mail, or you can WhatsApp on the, okay, so WhatsApp on the number. And rest, if you want to fill up the form here, you can fill and submit it. If you want any like query, you can just call freely. Okay, you can ask freely. If you want to see the content, you can see from it, both both of the that core and advanced. So thank you so much. Now next we will continue tomorrow. Hello everyone, Baba this side from JNtech Networks. So this is the session number 4 of Python series. Okay, so today we are going to discuss the typecasting, and we will discuss we will discuss the typecasting as well as we will discuss the operators. Okay, so in the previous sessions, we have discussed many things, like we have discussed the fundamentals. We have already discussed the into part of Python and the data types and the variables and the naming conventions and the rules of naming the variables. Okay, if you want to see the previous session, then you can go to YouTube. Okay, from there, you can search for the channel name, that is G2S5. Okay, from here, you can go here and then live. So in the live series, you can go for Python 3. Okay, day 3, Python day 2, Python day 1. Okay, so if your fundamentals are not clear, then you can first go and watch this videos. Okay, and then you can move to this session. So you can first go and watch those videos and then you can move to this sessions, like typecasting and operators. So what is typecasting? Typecasting is like changing your data type from one form to another, like changing your data type from one data type to another. So that we have already seen, like how to change your string into into integer, or how to change your string into float, or vice versa. Okay, now we will see how to change your tuple into list, or how to change your list into tuple, or dictionary into tuple, etc. So that we will see. So first we will see how to change the list into tuple, or the tuple into list. So let's make a file. We will put a type underscore casting. One second. Type underscore casting. The name of the file and dot py. Yes. Open this file inside your VS Code. Okay. Let me zoom in. Yeah. So first we will create a list here. So list underscore one is equal to in your list. Okay. Like anything inside your list. Okay. So this is a list. Now we want to change your list, which is immutable in nature. We have to change it into tuples. So you have to type, let's say, tuple underscore one. Okay, so we have to use tuple as a constructor here, and then list underscore one, and then print the type of list underscore tuple underscore one. See, basically we have created a list here inside square brackets. So anything inside square brackets are known as the list, and lists are mutable in nature. Means we can change the type of, we can modify the list, we can update list, we can add elements, and we can remove elements. And we have changed the list from tuples by using the tuple constructor here. So tuple underscore one is another variable. We are storing tuple inside this tuple underscore one variable. So we are calling the tuple as a constructor, and we want to change the list into tuple. So we are calling the list underscore one as a variable here. And then we are checking the type of tuple underscore one. Now your list becomes a tuple. When you run this program, see class tuple. Okay, now list is a tuple. And when you print the type of list underscore one, then this is a list. Okay, so basically list underscore one is a list, but we have changed the list into tuple, and we have stored that tuple inside tuple underscore one. So the type of tuple is tuple underscore one is tuple. Okay, and when you print the tuple as it is, then tuple underscore one. Okay, run this. Okay, so this is our tuple now. 1, 2, 3, 4 apple and cherry. Okay, same as like with the tuple, and like suppose we have a tuple here underscore one. Okay, same elements or different elements, like anything you can put inside tuples. List. Okay, let's say. Okay, now we can change the tuple into list by calling the list constructor here. So list underscore one is equal to list brackets. Now which data type you want to change? I want to change this data type. Means I want to change tuple data type, and this tuple is stored inside my this variable. So I will call this variable here tuple underscore one, and then we will print the type of list underscore one. You can name this anything, like just follow the rules of the variables, like how to name the variables. See, now this becomes a list. Previously, tuple is a list. Tuple is a tuple. Okay, because we have enclosed inside round brackets. Okay, and tuple is immutable in nature. Then we have created another variable, and we have called a list constructor here, and we are changing the tuple into a list. And then we have typed in a list that is now become a tuple. So we have like typing, we are checking the type of list. That is a list only. Previously it was a tuple, now it becomes a list. Okay, and if you check the type of tuple underscore one, print type of tuple underscore one, then tuple underscore one is a tuple only. Okay, but now we have changed the tuple into list and store that list inside list underscore one. So and when we are checking the list underscore one, now it is a list. Okay, you can name anything, like this might be confusing. So we can take another example. Let's say we want to convert set into list. Okay, so let's say we can put A is equal to, let's create a set here. So 1, 2, 3, 4, 5, and then apple. Okay, this is a set. So set are both immutable and immutable nature now. This is a set. When you print the type of set, type of A, see, this is a set. Okay. Now if we want to change the set into list. So we will create another variable and we will call the list constructor and then A. Okay. And then we will print the B, type of B first, and then B itself. That is B. Okay. So now B is a list, and inside list we have, inside B we have this list. Okay, but if we for same elements as set, because this is a set only, but we have changed the set from the list. Okay, so now this is converted into list. This is how you can change from one variable to another. Okay, same as with the set list, list set, or same as with another variables. Okay, but you cannot change list into dictionary or dictionary into list. Okay, because a dictionary follows some different syntax. Like dictionaries are the key value pairs. Okay, and list tuple and set, they are very straight. So we cannot convert the list tuple or set into dictionary and vice versa. Okay, but we can convert set into list, list into set, tuple into set, etc. etc. But we cannot touch dictionary or we cannot involve dictionary in it. This is known as the typecasting. Now we have the operators. So basically, what are operators? Operators are the like the symbols which is used to perform operations. We have the operators and we have the operands. Okay. What are operands? Suppose A plus B. Okay. So A and B are the operand. A and B are operand here. And plus is an operator. Okay. So this becomes a whole operation. So A and B are the operands and A and plus is operator here. Okay, so what are operators? Like Python and many operators, which is used to perform many operations. So we have arithmetic operators, we have assignment operators, comparison, logical, identity, membership, or bitwise. Okay, so let's see one by one. So we will put here operators. So first we have arithmetic operator. Okay, inside that we have plus, we have addition, we have subtraction, we have multiplication, we have division, and then we have floor division. And then we have modulus, and then we have exponent. Okay, this is arithmetic. Then we have assignment operators. So assignment we have equal, we have plus equal to, we have minus equal to. Okay, we have multiplication equal, division equal, we have division equal, we have exponential equal, we have modulus equal. Okay, then we have and equal, we have or equal, we have not equal. Okay, we have left shift equal, and then we have right shift equal. These are the assignment operators. Like we have plus equal, like we have plus minus multiplication and division. Okay, yeah. So we have these assignment operators. Now, what is the use of this assignment operators? We will see that. Then we have comparison operators. So we have equal, we have not equal to, we have greater than, we have less than, we have greater than equal, Okay, we have less than equal, greater than, yeah. And then we have, yeah, this much. We have the comparison operators. Then we have the logical operators. Inside logical operators, we have AND, we have OR, and then we have NOT. Then we have identity operators. Inside that we have is and is not. Only two operators. Then we have membership operators. Inside that we have in and not in. Okay, and last we have bitwise operators. Okay, in this we have the AND operator, we have the OR, we have the NOT, we have the unary, and then this one left shift and right shift. Okay, so these are the operators we have inside Python. So let's see one by one. So the arithmetic operators are used to perform the arithmetic operations. Okay, like addition, subtraction, multiplication, division. Let's see one by one. So suppose we have two variables a. Let's say we can use num1. Let's say 5. We have num2. Let's say 2. Okay, now print num1 plus num2. Okay, this is addition operation. Now copy this. We will paste it. This is plus. Okay, then we have subtraction. Then we have multiplication. Then we have division. Okay, then we have floor division. Then we have modulus. And last we have exponent. Okay. So plus means 5 raised to 2 minus and then multiplication. Now this division means we have one single slash and then we have double slash, which means, see, this single slash means the float division, which will give you the answer in floating point number. Okay, like for example, 10.2. If there is only like answer in the points, so this will return the point part also. So this means float division. Second, we have the, this is known as basically the integer division. Like 10, we have 34. Suppose 10, we have 34. So integer division will not show you the point part. Okay, this will eat up the point part. So we have only 10 and 34. Okay, so this is known as the float and integer division. Integer division, integers are like non-decimal numbers. So this will not show you the point part. Then we have modulus. This is known as the modulus. Now what is the modulus means? This will return the remainder part. Okay, suppose you have a 5 modulus 2. So 2 is divisible by 5. So when we divide 2, 5. So we have a 1 remainder because 2 into 2, 4. 5 minus 4, 1. So we have a remainder 1. So this modulus will return only the remainder part, that is 1. Okay. Then we have the exponent. Exponent means power of. Okay. It is like power. Suppose we have this exponent 5 exponent 2. So means 5 2 times 5 into 5, 5. This is not square or cube. This is like exponent. Let's say 5 5 5 into 5. Let's say 5 into 6. So means 5 6 times 5. So 5 into 5 into 5 into 5 into 3 4 5 6. Okay, so means 6 times 5. This is known as the exponent. Okay, so let's see in live. Okay, we have this addition, subtraction, multiplication, divisions, and then modulus, and then exponent. Run this. So we have the 7 for plus, then we have minus, then multiplication, then we have division, okay. Then we have the modulus. See, on line number 30, we have the simple division, like that is the floor division, which will give you the point part. On the next line, we have the integer division, which will not show you the point part. That is, dot 5 is removed from this. Only 2 is remaining. And the modulus will return the remainder part, and then exponent will return the exponent part, like 5 into 5, 2 times. Okay, you can change the value also, or you can use the value, or you can take the value from the user. Let's say int input, enter the first number, int input, enter the second number. Now the user can put the number. So we will run the program. We will run this from terminal. So use terminal here. Clear the screen, move to desktop, type Python in the name of a file. My file name is type_casting.py. Enter your name, sorry, first number, so 8. Let's say second number is 4. See, 4 plus 8, sorry, yeah, 4 plus 8, 8 minus 4, then into, and we have the float division and the integer division, and then we have the modulus. Why this is 0? Because when you divide 4 by 8, so 4 into 2, 8, so 8 is completely divisible by 4. So we have this 0 as a remainder, and then 8 4 times means 4 times 8. 8 into 8, 8, 8. Like, so we have this answer, exponent. Okay. So this is how we can perform the arithmetic operations. Where were we? Yeah. Then we have the assignment operators. Assignment operators are used to assign some values. That's it. Okay. Suppose you are assigning, let's move this. We have this value a is equal to 5. So 5 is a value, and this is equal to is an assignment operator, and a is a variable. So we are assigning 5 to variable a. This is known as assignment operator. So equal is also an assignment operator. So we are assigning 5 value to a. Okay, this is known as the assignment operator. Now plus equal means, suppose value of a is 5. Now we want to increment the value of 5 plus with 1 or with any number. Like a is equal to, we want a plus 1. So print a. So previously a is 5. Now we are incrementing the a value with 1. So now a will becomes 6. Okay. Now this is another way. If you want to write this in the short form, as you can see, a is coming 2 times. So we can short it, we can write in short form like a plus equal 1. So this line and this line both are same. Okay, but this line is a long form and this line is a short form of writing this 38 line. Okay, either you can use this or you can use the assignment operator directly. So both are same. So if you remove this, if you run this, we have 6 again. Okay, like you can put any value, you can put 100 also. So this will increment your a by 100. So now answer is 105. Okay, so this line, or you can even use a is equal to a plus 100. So both are same. But why we use assignment operator? Because the work of the assignment operator to write this in the short form. Okay. So whenever you are using the assignment operator, make sure that your main operator, that is plus, minus, multiplication, division, is in the first, and then the equal sign. Okay. Like we have the plus, multiplication, and minus, and division in like first, and then the equal sign. Okay. Now let's say another example. Suppose we have a and 5. Now we get a multiplication is equal to 6. Now what is the value of a is now? Previously a is 5. Now the value of a is 30. That is 6 into 5. Okay, so we have 30. You can write this, or you can even write like this. That is 6. Okay, so both are same. But we always prefer to write like this. Okay. So always use this as an assignment operator. Don't use this. This is just a bad form of writing a code. So we will always prefer to write this. Okay, the short form. This is known as the assignment operator. And this is the only work of an assignment operator, to assign some values or to make some changes in the previous values. Then we have the comparison operators. Comparison operators, as you can see, to compare the values. Okay, suppose let's say if we will use a statement like what is if, what is else, we will see that later. Okay, we will see if a, let's say if 5 is greater than 6. If it is 5 is greater than 6, then print yes. Okay, and else print no. Okay, don't worry about this if statement, else statement. We will cover this in later. First, focus on this uh, comparison operators. So, comparing operators like we are comparing the values. So, you check if 5 is greater than 6, no. So, this will return no. Okay. So, comparison is like comparing the values. You can even write like this print is 5 is greater than 6. Okay, and the answer will be true and false. False. Because 5 is not greater than 6. Okay, let's say 5, let's put here 4. So now 5 is greater than 4, yes. So this will return true. Okay. Same is with the less than equal sign. Now, if you want to check whether two numbers are equal, so you have to use double equal sign for that. Okay, we are checking 5 and 5 are equal, yes. So this will return true. Or if no, like 5 and 7 are equal, no. So this will return false. Okay, if you want to match two values, if you want to compare two values, whether two values are similar or not, you have to use double equal sign. Because why we are not using the single equal? Because single equal sign is used for assigning something like a is equal to 6. So we use single operator here, single equal sign here to assign some values. So single equal is occupied with something else. So we have to use double equal for comparing the values. Okay. Now, if you want to check not equal, then we will use this one, exclamation mark and 6. Now, 5 is not equal to 6. Yes, 5 is not equal to 6. So the answer is true. Now, if we check 5 and 5 are equal, yeah, 5 and 5 are equal, but we are checking 5 and 5 is not equal. So this will return false. Okay, like it is just the opposite of equal sign. So we have this comparison operators. Okay, double equal means suppose we have this equal 5. So we are checking whether we are checking two conditions whether the number will be greater than or equal to 5. So number is equal to 5. So this will return true. Or we can put here 7 also. This will also return. This will return false basically. Now when you put 4 here, this will also return true. Okay, because we are checking two conditions here. The number should be greater. Here we are checking the number should be smaller than 5 and equal to 5. Okay, so the 4 is smaller than, or we can put here okay, so these will return true. But now we have this number 8. So 8 is greater than 5. So neither the 5 and 8 is like less than or equal. Not equal. Okay. So we will this will return false. Okay, so this is the use of greater than. You can use same as with the less than. They both are same. Like both are opposite. So you can use the comparison operators for comparing the values. We mainly use the comparison operators in the if statement. Okay, like if statement and loops, basically. Okay, now we have the logical operators. Logical operators means and or not. See, and means both conditions needs to be true. Like suppose we are checking for, let's say, we have one value. We have, let's say, 5 is greater than 7 and 5 is greater than 4. Which one is true? This one is true as we know 5 is greater than 4. Now 5 is not greater than 7. So AND operator means both condition needs to be true in order to print true. Like if you print this one, so this will return false. See, we have this false because we know that this condition is true. We know that yeah, 5 is greater than 4, but 5 is not greater than 7. So this will print false because in the AND operator check both condition, the left one and the right side, both condition. If the both condition is true, then only the AND operator return true. Suppose this is 3. Now this condition is true and this condition is true. So we have now true answer. Okay, so AND operator means both conditions, the left side and the right side, needs to be true. Now, but with the OR operator, we have OR. In the OR operator checks only for the one condition. Okay, suppose this one is 7. Now we know that 5 is greater than 4, but 5 is not greater than 7. But this will return true because OR will only satisfy on the with the one condition. Means this condition is true, but okay, and so OR will only check for the one condition. Like only if only the one condition is true, I will return true. Let's say this is 8. Now here both condition are false. This is false and this is false. So the answer will be false. Okay, and we have this 3. Now this condition is true, but this condition is false. So the OR will return true because OR will check only for the one condition and will check for both conditions. Okay, and not is opposite of what is like not is like opposite of everything. Okay, like we can check if A is not B. Okay, so this is like opposite of everything. This is logical operators. Now identity operators. In this we will check for the similarity. Like this one is similar to this one. Okay, for example, we have A is equal to apple and we have B is equal to apples. Or we can just put any name for avoid confusion. Oranges. Okay, now we're checking print A is B. Okay, we are checking that A is B or not. So when you run this, this is false because we are checking that A is equal to B or not. Basically, A is not equal to B because this is operator. We check for the character by character. Okay, so apple and oranges are very different. So this will return false. Suppose we have apples. Apples. This will still return false because the is operator we check character by character like A is equal to A, okay, double P is equal to double P like LE. Now where is S? We have an extra S in B, but we don't have any S in A. So this will return false because the is operator will check character by character. Okay, you can check for the number also like 10. Now here we are checking A is B. No, because A is not equal to B. So false is the answer. Now A is B. Yes. So true. Okay, identity means you have to check for it. We like check that one variable is similar to another variable or not. Okay. Even if you put data type like here, and when you run this code, now 10 is a string and B is a number. So this will also return false. Okay, so this will also check for the data types. Now is and is not. Is not is opposite of is. Okay, let's say so we are checking A is not B. Okay, we have a statement. We are just telling a statement that A is not B. Yes, A is not B means A is not equal to B. So this will return true. Okay, true. And let's say if we are printing if A is B. Okay, now A and B are equal, but still we are making a statement that A is not B. So this will return false because A and B are equal and we are making a statement A is not equal to B. So this will return false. Okay, like is not like is opposite of is not. Is not is opposite of is. Like sounds confusing. So we can put is and then here is not. So is opposite of is not. Okay. Like this is totally opposite of is. Yes. Opposite of is operator. Okay, this is known as identity operator, where we are checking for the similar identity. Now we have membership operators. Membership operators, like we are checking whether a particular string, whether a particular character, or whether a particular element is a part of this member or not. Suppose we have a list here, list underscore one. Okay, let's say we have a list of numbers. Okay, so we are checking that 5 in list underscore one or not. Okay, so we have a list of numbers 1, 2, 3, 4, 5. Now 5 is a member of the list. So we are checking if 5 in list or not. Yes, 5 in list. So this is written true. Okay. Now then we can check for 4. Let's say 7. 7 in list. No, 7 is not the part of the list. So this is written false. Okay. So here we are checking that whether a particular element is a part of something or not. Okay, this is a list. Let's take a variable here. Let's say we have a string here, apple. So we can check that if the character A in A, like if we are checking that character A is the part of the apple or not. Okay, so this will be written true because A is part of the apple. Now let's say we are checking for Z. Like here we are checking that Z is a part of apple or not. So no, so this will return false. In now same is not in. Not in is opposite of in. Okay. Now if we are making a statement that Z is not a part of A, and this is true because Z is not a part of apple. So when you run this, we have true answer. Now let's say we have the P. Okay, and we know that P is a part of apple, and we are making a statement that P is not a part of A. So this will return false. Okay, so like this is basically the opposite of in. Okay, so these are the membership operators. Now, last we have bitwise operators. Basically, they are used for the binary operations like AND. Same as with the AND or, and this is not. Okay, unary, left shift and right shift. AND means suppose we have a given binary. Let's say 1010 like this one. So we have the 10101010. Okay, 8 bit, and we are performing any operation. So end means this end means one is one, rest are zeros. Like 111, okay, 010, 111, 010, 100, 000. In this end operator, we are checking for the if one and one are equal, like if one and one and one, then only we have the answer 1. Rest are zeros, like 10 are zeros, zeros are zeros. Okay, here we have performed the end operator, end operation here in the binaries. So we are checking 1 and 1 or only ones and rest are zeros, like 100, 111, 100, 100, and 000. Okay, so this is the end operator. Or operator, like one needs to be one, like 111, 011, 111, 101, 00 is only 0, 10, that is 1, and 000. In this, only one needs to be 1. So that we have the answer. Okay. So we have 0, 1, 1, and rest are the zeros. Like 111, 100, sorry, 101, 111, 101, 101, and 000. Okay, means 00 is only 0 and rest are the ones in the OR operator. Because OR operator we check only for the one condition. And if there's only one at any side, we have the answer at 1. Okay, AND operator we check for both conditions. Okay, this is the OR operator. Then we have not operators, which means 0, 1, 1 and 1, 1, 0. Okay. So we have, sorry, XOR, not XOR. Okay. So we have 0, 1, 1. So we and 1, 1, 0. So 1, 1, 0, 0, 1, 1. 1, 1, 0. Means single ones are 0 and rest are the ones. Okay, 1, 0, 1, 0, 1, 1, 0, 1, 0, 0, 0. Okay, and 1, 0, 1 and 0, 0, 0. So this is the XOR operation. Then not operator, basically the unary one, not. In this we only needs only one bit, only one binary. Okay, in this we have, this will reverse your binaries. Like one becomes 0 and 0 becomes 1. So 1, 0, 0, 1. Same as 1, 0, 0, 1. Like this. Your 1 becomes 0 and 0 becomes 1. This is like sounds complicated. Basically, this is the background, like how this Python process this AND operator or operator in the background. Basically, we are the developer, so we have to know what is running, what kind of code is running in the background. So that is why we are understanding these operations. Okay, then we have the zero left shift and right shift. So we have this. This is known as zero fill left shift, and this is zero fill right shift. Okay, means suppose we have a binary, let's say left. Okay, suppose we have a binary 1, 0, 1, 0, 1. Let's 1, 1, 0, 0. Okay, let's say we are shifting it to one variable, one. Okay, only one. So this means one will shift to left. Okay, for example, we are shifting this one. So we have the 1, 0, 1, 0 as it is. Now we are shifting it to 1. So 1 will shift to left. So basically we have the answer 1, 1, 0, 0. This is the quotient. So we are shifting this one bit to left side. Okay, so this remains empty. So this is shifting from one place to another. So let's say this is the now empty space. Now this one is shifting to left, 0. So 0. So at place of 0 we have the 1. 1. Okay, and this 0 will shift to left and this 1 will also shift to left. So we at place of 1 we have 0 and at place of 0 we have 1 and at place of this 0 will also shift and we have 0 here. And this 1 will lost somewhere. Okay, and then in this empty space we have the 0.